what you did right here. How do you feel about what's going on with exponents? Yeah, it's nice that it's generally positive or neutral. I kind of share that view. Exponents are there, and that's about it. They're there, which is good. It's cool if you like them. I like the simplicity that comes in a nice solution. Yeah, get the negative exponents out first. So here's what I would do if I was going to do that. I would turn it into, yeah, can you turn off the lights? Thank you. What can you do with this right here, this x to the negative 2 right here? What could you do with that just to simply get rid of that negative 2? 1 over, right? But where does that put that x to the negative 2? It turns it into x squared and puts it downstairs. Yeah, I like that. So you could turn this into 4 over negative 5 squared x to the 4th y squared. But then you take that x squared and move it down. Take the yz to the negative 1 and move it down. But what do you put up top? Yeah, the z to the 2. All we've done there is it pops it up to the other side. That's it. So we got rid of the negatives. And now what are we going to want to do to simplify this? What would be a small step to take? Yeah, combine the terms that can be combined. So you end up with, let's say, 25 x to the y to the 3rd z. And what's the last thing you need to do? Cancel z. So you end up with 25 x to the 6th y cubed. Is that correct?
Yeah.
Good.
Can you move it back? Like separately?
Yeah. I'm sorry, can you move what back?
Like 4 over 20.
Yeah, you could. Yeah. I like this, though. That's how I would like it. That's how I would like it. Yes.
I think I got the same answer, but I didn't fully simplify it, so it's 4 over 25, x to the negative 6, y to the negative 3rd, z.
Yeah, that's fine. In general, you're aiming for positive exponents. In general. But that is correct, yes. 49. What's the added fun to 49? Yeah, more fractions. The way I would do this, I'd flip that over. That's what I would do first. What do I do next? Someone tell me concretely, specifically, what I should do next. Yeah, kind of do out the exponents. Yeah, exactly. So end up with y squared over x squared times y to the 4th over x to the 4th, all over x squared y cubed. Yeah, so what's that top become?
Y 6 over 6 x 6.
All over.
X over y 6.
So when you're dividing by something, it's the same as multiplying by the reciprocal, so it's y to the 6th over x to the 6th times 1 over
X squared y 6.
So what does it turn into? Y to the 3rd over
X to the
8th. Very good. Exactly. So I would imagine you picked those because they looked visually the worst. I'd imagine, yeah. I mean, there's no right answer to this, right? There's no answer that says like one of these is the worst. There's no like magical formula. Any other ones pop out at you as being particularly challenging on any of the ones on this through 60? Any of them?
Can I?
Any of them 1 through 60? No, anyone you want.
55.
Which one, Victor? 40? Did you say 40?
Yeah.
So that one right, sorry. So this one right here? Victor, is that one?
Yeah.
That one? Now what do you do with that negative power? What can you do to get rid of the negative? Surely just the negative. Flip it. So that equals 3 over to the 1. And you're done. I mean, when they say simplify, basically they mean try to get rid of as many of the fractions as you can and reasonably get rid of as many negative exponents as you can. Reasonably. There's no one way that's best, but I generally like smaller positive numbers. Small positive whole numbers, right? Okay. Anything else on this entire page? Anything else on this page?
57 or 58?
57 or 58?
I just want to know, do we need calculators?
No, you should be able to plug in those numbers in either in your head. Yeah, you're just plugging in 2 and you're plugging in 1. No, there's nothing special at 50. There's no trick to 57 or 58 other than just that's a reading comprehension question. That's plug in 2 for x and do it out. Plug in 1 for x and do it out. That's it. Hey, how would you go about What about 60? How would you guys do 60?
Combine the base.
What do you think?
We don't need
Exactly. And to answer your question, should you use a calculator? No. Is it much of a problem if you use a calculator? Not really. Like that?
You can combine bases, correct?
You could, because it's the same power, right? So what is it going to be? 1/10 times 20 to the third, which is 2 to the third, which is 8. Another way to think about this too, just one other way to think about this. What is 10? I'm just going to try to I'm going to try to show you a side way. It's longer and not the method you would use, but it's a good exercise. What is 10? What's a way to write 10? 2 times 5, right? And what's 20? 2 times 2 times what? To the third. Right. So you could, if you wanted to, you could write it out like this. 1 over 2 to the third, 5 to the third times 2 to the third, 2 to the third, 5 to the third, right? What cancels? And what are you just left with? That's another way to look at it, okay? Just to look at it. There are times when you're going to need to do that to simplify nicely. What about 59? Is that what you said? 59? Yeah, you got to be real careful. What, 666 to the fourth, 222 to the fourth? That's exactly what we just did. That's good. 666 to the fourth over 222 to the fourth. So that's 66. What is 666? 3 times 222 to the fourth over 222 to the fourth. What do you do with that exponent on top? Yeah, just kind of do it in. Yeah, 3 to the fourth times over. What cancels now? Which is what? 81. Yeah. Yeah. Do you ever want to actually do out 666 times 666 times 666? No. Again, smaller better, right? Yeah. Good. Much easier. It stays nice for a little while. Let's say you put $100 into account, and every year, once a year, it earns 10%. So time in years, amount in the amount in the account. So time in years, after 0 years, there's going to be $100 in the account. You're putting it in. After 1 year, how much money is going to be there? 110. After 2 years, how much is going to be there? 120. If you're doing simple interest. If you're just doing interest on the original amount. More likely, though, how much is going to be in there? $121. How did you get from here to here? You did 100 plus what? 100 times 10%, which is 0.1, yes. And then you had 110. How'd you go from there to there? You did 110 plus what? Times 10%. Ah, so we're talking about, that's the topic today, compound interest. Can someone say really simply what compound interest means?
That instead of just having...
No, don't say instead, just what is it?
It's an interest rate in which you get money based off of the amount that's currently...
Can you use, you have 3 words. You get 3 words. Interest on interest. That's the difference between compound interest and simple interest. So we're talking about, all of what you said was correct. That is totally correct. Interest on interest. So the idea is once you earn the interest, where does it go? Into the account. It doesn't go off somewhere separately. The interest doesn't march off and go start its own little account. The interest goes straight into the account. The interest goes straight into the account. Okay, so after 3 years, how much money would you have? How would you figure it out? You do 121 plus what? Times 10%, right? Anybody know what that is? Can you do that in your head? 132 point what? Yep, $132.10. Okay, so let's look at what we did here. After 1 year, we had $100, right? At the end of the year, we added $100 times what? 0.1, right? So this was the money after 1 year, correct? If we wanted to then get the money after 2 years, you take that, that's the amount you have. What do you add to it? The amount here times what? 0.1. Now this can get really complicated really quick, trying to keep the hundreds and the point ones all separated. So let's take it apart into pieces. Let's simplify it in pieces. Meaning, after 0 years you have 100. I'm going to do the same chart, but we're going to write it a little different. After 1 year you have 100 plus what? 100 times what? 0.1, right? What's in both of these terms? 100. So what does that equal? 100 times 1 plus 0.1, correct? So after 2 years, you have your new amount, which is 100 times 1 plus 0.1. And what are you adding to it?
100 times 0.1.
1 plus 0.01 times what? You're adding 10% of what you just had, right? Correct? You're adding 10% of what you just had? Are you following me so far?
Yeah.
Can someone tell me what's in both of these terms? Yeah. So what can you do with each of those terms? 1 plus 0.1 times what? 1 plus what? 0.1, right? How many of these terms do you have? You have 2 of them. So what does this simplify to? 100 times 1 plus 0.1 to the what power? Squared. So this right here is after 2 years. That right there is after 2 years, exactly. This right here is after,
1 year.
let's do it one more time. If we do it one more time, 3, right? You have 100 times 1 plus 0.1 to the second power. And what are you adding to it? 100 times 1.01, actually 1.1 plus, sorry. I'm trying to keep it separate. 0.1 squared times what? 0.1, exactly. All we're doing is adding 1/10 of what we had. What's in both of these? Yeah, this is in both, so what can we do? Factor it out. 1 plus, and I keep on writing that point there. 1 plus 0.1 squared times what? 1 plus 0.1. So what does that turn into? 100 times
1 plus 1.
to the what power? Cubed. Are you starting to see a pattern here? Yeah. So what's the easy thing to see? Well, the easy thing to see is the 3 goes from there, and there's the 3, right? So if this is n, sorry, no, I'm not using n, time. T time. What do we now have? We have to the t power, where t is in years. Yes, we're using years. Got it. What does that 100 represent? Ah, you got it. Someone said it right there. The original value, right? The original amount of money. That's called the principal. The principal. Principal. So that's P. It's the starting amount. So where does that go? Right in front. What's that 0.1? What does this represent? This is the interest rate. In what units? Is it in percentage? In decimal, yes. So this is one of the places where you have to use decimal. And we're going to use R for the interest rate. And what's the one thing that stays exactly as it is? 1. The amount you have is P, the principal, the amount you started with, times 1 plus the interest rate to the t power, the number of years, yes. To the number of years, absolutely. So, let's focus on this, and then you can ask questions about anything you want afterwards. Pretty much anything. What does this formula allow us to do? Well, Justin, give me an amount of money. Denise, give me, what do you got?
$4,000.
$4,000? Sure. So we have $4,000. Denise, give me an interest rate. In percentage. What percentage? No. What? 100%? 20%? Sure. Yeah, nice. You're Bernie Madoff. How many years? Just pick a number. Pick any number you want. Jarrett. Steven.
Oh, I think it was
No,
4.
I'm sorry, 4. Okay, so here's the question. If you put $4,000 into an account earning 20% interest for 4 years, how much money do you have at the end of the 4 years? Do that on your calculator right now. Okay, so here's the harder question, though. So let's say instead of doing, computing interest once a year, let's say we computed it twice a year. So let's say we had $4,000. $4,000 at 10% twice a year for 4 years. Does this look to be, don't do it yet, does this look to be about a similar, is this a similar situation?
Yeah.
Instead of doing 20% once a year, we're doing 10%
Twice
twice
a year.
a year. So let's do this formula. It's going to be 4,000 times 1 plus what?
You do 0.1 over 2.
0.1 times 2. Oh, wait.
10%, so 10% twice during the year. We're not breaking 10% apart. We're doing 10% twice. So every 6 months, we're just going to do 10%. Every 6 months, we're going to do 10%. So it's going to be 0.1. Now here's the question, to what power?
8.
8, because how many times are we compounding it? 8 times. Got it. Okay, so do that out. Can someone just tell me what that is on your calculator? 8574 point what? Can someone verify that for me?
Yep.
Identical. Can someone explain to me why isn't it identical in one sentence? Why isn't it identical? Yeah.
Interest on interest.
What?
Interest on interest. Because you're compounding it twice a year.
You're compounding more. You're compounding more.
The time
Compounding more. So the point is, the more you compound, what's going to happen to the amount of money you earn?
the more money.
The more money you're going to make. So interest is being calculated on the interest. For example, what's worth more, $1,000 now or $1,000 a year from now? Yeah, because $1,000 now, what could you do with it? It could earn interest for a year. $1,000 right now, you can earn interest on it for a year. But if I get $1,000 at the end of the year, do you have a year to earn any money on it? Money over time is money. The earlier you get a payment, the sooner you can put it into the bank and start earning money on that payment. Does that make sense, everybody?
Yep.
So that's why paying early, sometimes it costs less to pay early, because over time, that money grows. Yes? No, they don't do interest twice a year.
They do simple.
They do not do simple interest, no. What do banks do? So here's the question. Okay, so I have a question for you. What did we just do? Where did this 8 come from? This 8 was our number of years times what? Where does that 2 come from? Twice. And where did this come from? That was 20% divided by 2. So usually, this is a broken question because usually you always say the interest rate in the yearly percentage rate. And when I say twice a year, what does that mean? If I say 20% twice a year, I'm going to start this off now. I shouldn't have started off that way. 20% twice a year means 10% twice. So let's just divide by things that make it easy to write the decimals. So let's say you had 4,000, 20% yearly interest. So interest is always going to be stated as yearly. But instead of twice a year, let's do it quarterly over 4 years. What's the formula going to be that I plug in? 4,000 times over what? Over 4 to the 4 times what? Times 4. Someone do that on their account. Do a few of you so you can verify your answer. Daily interest. Same account, same amount of money, same yearly interest rate. Be careful, you have to type in the numbers really carefully. What do you get? 8,900 point what?
19.
So do we make more money? Yeah, but did it suddenly get to $1 billion trillion? So try this for me on your calculator. Do this. Type in like 1, 2, 3, 4, 5, 6, 7, 8. And then store that using the STO button as A. Everybody store that as A. This is a really easy way to, so on your calculator, do 1, 2, 3, 4, 5, 6, 7, 8, and store it as alpha A. What does that mean? It means when you type A, alpha, and then A is right above the math button. So anytime you call A, what number is it now? 1, 2, 3, 4, 5, 6, 7, 8. This is really helpful if we're going to use a big number multiple times. What happens if you don't type in the same number into this formula, into the compound interest formula? Meaning, over here, and let's say we typed in 360 here, but 390 right there. Does it break? Does this number have to be the same as this number? Yes. What happens if you write the wrong number? It breaks completely. So when you deal with bigger and bigger numbers, does it get more and more important? Yeah, so would you consider this to be compounding it pretty quickly? Yeah, it's pretty quickly. So type this into your calculator. 4,000 times 1 plus 0.2 over a to the 4 times a power. So that's 4,000 times 1 plus 0.2 divided by alpha a to the, in parentheses, STO. It's right there in your calculator. STO. Right there.
Is that 4 times there?
Oh, I did it wrong. Thank you. Second entry. You're absolutely right. Good job. What did I get? So when I typed it in, did I get more money? How much more money? Like $2 more. So we went from daily interest to like every instant, right? Almost every instant. So do you make more money? Yes, but are you going to get an infinite amount of money? No. There's a limit to it. There's a ceiling that you can get really, really close to. So you can always get higher, but what happens as you get higher? It slows down, right? Yes, it is identical. It is coming to an asymptote. So the question is, what is it if you compounded it every single instant? Every single instant. And I can't prove it every instant. It's called something with a C. Yeah, you could say that would actually make sense, but continuous interest. And this is actually a simpler formula. Interest, if I could just spell it. A equals P times E to the RT. What's P? R? T? Time is in? R is in? Decimal. Yes, not percent. Don't do it in percent. If you use percent instead of decimals, your answers are going to be really silly, right? Because what's 20 in terms of growth rate? A 20 would be worse than that. That's 2,000%. That's a fast growth rate. So let's do this. What's continuous interest going to be? What's the most amount of money? E to the 0.2 times 4. So you do that out, you get 4,000. Second, e to the 0.2 times what? 4, right? Look at that. So continuous interest. What did continuous interest give us?
Almost the same number.
Almost the same number. Very, very similar, right? Sometimes it gets to a point where it doesn't matter anymore, right? What kind of interest rate do banks use? Be more specific. Continuous interest. Continuous interest is compound interest. It's a kind of compound interest. So why do banks use continuous interest? Overall, that comes out to be a huge mistake, right? But is that a very complicated mistake? No. It's really simple mistakes that you have to be careful about. Really simple mistakes that you have to be careful about.